Hi everyone. Today we're going to study more sample problems for velocity and acceleration. First, let us make a short review for velocity and acceleration. Let S equals f of t represents the function of a moving object, say a car. Velocity, or we say instantaneous velocity, is the derivative of position with respect to time. So we write here v of t, where v stands for velocity. And this is equal to the derivative of this function. So we write here ds over dt. Now, acceleration is the derivative of velocity with respect to time. So we write a of t, where a stands for acceleration. And this is equal to the derivative of this function. So we write dv over dt. Or we say that this is the second derivative of the function s equals f of t. Let us see this example 1. At time t, the position of a body moving along the s-axis is s equals t cubed minus 6t squared plus 9t. Letter A, find the body's acceleration each time the velocity is 0. Letter B, find the body's speed each time the acceleration is 0. For our solution, let us find first the velocity, and that is v of t. This is equal to the derivative of this function. So ds over dt equals 3t squared minus 12t plus 9. Next, let us find a of t. This is the acceleration. This is equal to the derivative of this function here. So we have dv over dt equals 60 minus 12. Now, let us solve for problem A. The step 1 is we're going to set the velocity function equals 0 and solve for t. So this function here now becomes 0 equals 3t squared minus 12t plus 9. We can see here that the terms of the right side have common factor, that is 3. We can factor out the number 3, so we have 3 times the quantity t squared minus 4t plus 3. If we're going to divide the equation by 3, this equation is simplified into 0 equals t squared minus 4t plus 3. Now, let us solve for t. We can see here that we can solve this by factoring. So we write 0 equals the quantity t minus 3 times the quantity t minus 1. Let us equate both factors to 0. So we have the t minus 3 equals 0 and the t minus 1 equals 0. Solving for t, we have the values t equals 3 and t equals 1. These are the values of t when velocity is 0. Now, for step 2, we will evaluate the acceleration function at t equals 3 and 1. These are the values that we get from step 1. Let's begin with a of 3. This is equal to 6 times 3 minus 12. The 6 times 3 gives 18. Then minus 12, we have 6 as the answer. Next is a of 1. The same function that we will use, and this is now equal to 6 times 1 minus 12 equals 6 minus 12 equals negative 6. So we have the answers for letter A. Let us write the answers below the problem A. So we have a of 3 equals 6 and a of 1 equals negative 6. Now let us solve for letter B. This time we have step 1. Let us set the acceleration function equals 0 and let us solve for t. So we have 0 equals 6t minus 12. Solving for t, let us transpose this negative 12 to the left side. So we have now 12 equals 6t. Isolating the t, let us divide both sides by 6. So we have 12 over 6 equals t. So the value of t equals 2. This is the value of t when acceleration is 0. Now for step 2, let us evaluate the velocity function at t equals 2. This value 2 is what we derived from step 1. So we have now v of 2 is equal to 3 times 2 square minus 12 times 2 plus 9. Simplifying this, we have now 12 minus 24 plus 9. And the answer here is negative 3. Take note that we are looking for the speed, and the speed is equal to the absolute value of velocity. So taking the absolute value of negative 3, the speed is equal to positive 3. Let us write this answer down the problem B. We are now able to write the final answers for example 1, problem A, and problem B. Let us see example 2. At which time t, the average velocity equals the instantaneous velocity of the moving particle s of t is equal to t square minus 3t plus 2 over the time interval from 0 to 2. For our solution, we will equate instantaneous velocity and average velocity and solve for t. So we will write here ds over dt equals f of b minus f of a all over b minus a. Take note that the ds over dt is the instantaneous velocity, while the right side here is the formula for the average velocity. Now, with respect to our time interval, the right side of the equation becomes f of 2 minus f of 0 all over 2 minus 0. Let us evaluate both sides of the equation. ds over dt is the derivative of our function. So we have now 2t minus 3 is equal to, the right side here now becomes like this. The f of 2 is now 2 squared minus 3 times 2 plus 2. Then minus, the f of 0 is now 0 squared minus 3 times 0 plus 2. All over, the 2 minus 0 here is simplified into 2. Simplifying the two big groups in the numerator, we have 0 minus 2 all over the denominator 2. So the numerator here now becomes negative 2. And when we divide this by 2, we simplify the equation into 2t minus 3 equals negative 1. Let us now solve for t. Let us transpose this negative 3 to the right side. That becomes positive 3. So we have the right side, negative 1 plus 3 is now simplified into positive 2. Dividing both sides by 2, we have t equals 2 over 2, so that t is equal to 1. This is our final answer. I hope you learned something from this video. See you again next time.